Hello class, welcome to the next lesson in 8th grade Eureka Math. Here we are still in Module 4 working on Lesson 12 today. Lesson 12 is called Linear Equations into Variables. And it is really strongly connected to Lessons 10 and 11, where we wrote linear equations, we solved linear equations, we put them in a table, and we graphed them. We're doing much the same thing today. So you will need your pages 123 to 133 of your Module 4 workbooks to help you today to put your work on. You will also probably need some graph paper so that you can graph the results of your tables. We're going to take an equation, fill out a table, then we're going to take the table, make some coordinates, and we're going to graph. And this time they do not give you the axes. You have to make the axes yourself today, but we'll show you how to do that. So make sure you have some graph paper, make sure you have your writing tools, make sure you have your workbook pages, and make sure you are writing down these notes that you see on the screen, starting with the vocabulary. And again, a reminder, if at any point you need to pause the video and finish writing a vocabulary word or finish writing a note, or if you ever need to go back and re-watch part of the video, that is perfectly good. You are allowed to stop the video, to pause the video, to catch up with writing. You are allowed to go back and re-watch parts that you need to see one more time. That's the beauty of these lessons on video. You control how fast you go, and you control how many times you need to watch something, how many times you need to hear something. But we have 4 vocabulary words today. First one is a linear equation into variables. Very good, because it's the name of our lesson. A linear equation into variables. Well, we've talked about a linear equation before. A linear equation is an equation for a line, for something that makes a straight line. So it is constant change. But it's a math statement with an equal sign. So an equation has an equal sign. But with an equation with 2 variables means that this equation uses 2 variables. Most of the time, x and y. Now, earlier in Module 4, we were doing linear equations with 1 variable, and we were just using x. Today, we're going to be doing linear equations in 2 variables, x and y. So linear equations and linear equations in 2 variables are pretty similar. The only difference is 2 variables, we have y in there also. Next vocabulary word, standard form. Standard form is a way to write an equation. It's a way to write an equation. Standard form equations are written like this. ax plus by equals c. This is standard form when the variables are on the same side. Standard form is when the variables are on the same side. We have x and y both on the left. X and y both on the left. A, B, and C are all numbers. They can be 1, 0, 2, 3, any number you want. But the standard form has both variables on the left side. That is standard form. And we're going to be writing equations in standard form today. Next vocabulary word is fixed value. A fixed value is a number given for a variable. So if you have a linear equation with 2 variables and you say x equals 3, 3 is the fixed value for x. 3 is the number that you gave for x. So a fixed value is a number that you give for a variable. So you can choose what your fixed values are when you solve equations. So you say x equals 3, and then you use the fixed value of 3 for x to find out what y equals. So fixed value is a number you give for a variable. And our last vocabulary word is ordered pair. Ordered pair is another word for coordinates written for graphing on an xy axis. So you've seen ordered pairs before, you've graphed ordered pairs before, but it's just a reminder of the definition for an ordered pair. They are your coordinates for xy axis graphing. And you write them in this order. X has to come before y when you write an ordered pair. They go in order, x and y. If you ever get confused about which one comes first, just remember when you do the alphabet song, X comes before Y in the alphabet, so X comes before Y when we write an ordered pair. X and then Y. So those are our 4 vocabulary words. Linear equation in 2 variables. Standard, which is using X and Y. Standard form, which is how to write the linear equation with X and Y on the same side. Fixed value is a number we give for a variable. And ordered pair is how we write our coordinates down. Ordered pair is how we write coordinates. So that's the vocabulary. Let's talk about what we're going to do today. Today, we will use a table to find solutions to a linear equation and then graph the solutions. So we're going to use a table to find solutions and then graph those solutions. So they'll give us the tables, and in many cases today, they'll give us the equation. But we're going to practice using the equations to find coordinates and to put them on a graph. Now, there are a couple tricks today where it might be a little bit, there are a couple of ways to solve the equations that make it easier. If you do not listen, you're probably going to make your life more difficult. So make sure you're paying attention today about how to use a table, how to fix values for an equation, how to solve the equations, and how to graph using coordinates. But the first thing we're going to do today is we're going to start with kind of an exploration activity, and we're going to talk a little bit about basketball. So let's start on page 123 of your workbook. Again, if you need to pause and go back and rewatch any parts of these notes, go ahead. But I'm going to move ahead, and we're going to look at page 123, opening exercise. And we're going to talk about Emily. Emily tells you that she scored 32 points in a basketball game. Write down all the possible ways she could have scored 32 with only 2 and 3 point baskets, which means no free throws, no 1 point baskets. Use the table below to organize your work. Okay, well, let's look at this. We know that she scores 32 points. So the number of 2-pointers and 3-pointers have to add up to be 32 points. Now, she didn't tell us how many shots she made, but we can figure it out. So, for example, 2-pointers, if you make 1 2-point shot, that gets multiplied by 2. Multiplied by 2. 2-point shots give you 2 points. So every shot you make gets multiplied by 2. If you make 1 shot, you get 2 points because 1 times 2 is 2. You make 2 2-pointers, that's 4 points because 2 times 2. 3-pointers, every shot is multiplied by 3. Every shot gets multiplied by 3. Now we're going to use this information to figure it out. How do we make 32? How do we make 32? Well, if she makes 0 3-pointers, that makes 0 for 3-pointers. Which means she needs all 32 points to come from her 2-pointers. Well, that's going to be 16 2-pointers. 16 2-pointers gives her 32 points for 2-pointers. 0 3-pointers give her 0 points, but 32 and 0 together make the 32. So you see how that works. We have to take her 2-pointers and her 3-pointers together have to equal her total points. Let's say she makes 1 2-pointer. 1 2-pointer. Well, 1 2-pointer times 2 points means she gets 2 points. Which means if she gets 2 points from 2-pointers, she needs 30 points from 3-pointers. Because we need 2 and 30 to make 32. Well, how many 3-pointers does she need to make 30 points? That's 10 3-pointers. So 1 2-pointer and 10 3-pointers will make 32 points. What I'd like you to do now is pause the video and see how many other combinations you can come up with to make 32 points. There are not an infinite number of combinations. Make sure it works. You have to add up to exactly 32 points. So, like, for example, one 3-pointer will not work because one 3-pointer will need 29 points from 2-pointers, and that's impossible to do 29 with 2-pointers. So you need to start thinking about how many. So pause and start thinking about how many. So pause the video and see if you can finish the table. Sorry, pause the video and see if you can finish the table. And then when you're ready, unpause the video and come back and we'll talk about it. Okay, so hopefully you thought about it a little bit and you figured out some of the answers here. So for example, she can do 2 3-pointers and get 6 points from 3-pointers. But that means she'll need 26 points from 2-pointers, which is 13 2-pointers. She can also do 4 3-pointers and get 12 3-pointer points. But that means 32 minus 12, she'll need 20 2-pointers. 20 points from 2-pointers, which means 10 of them. She can also do 6 3-pointers. 6 3-pointers makes 18 points. 32 minus 18 means that she needs 14 2-pointer points, which is 7 2-pointers. The last one, she can make 8 3-pointers, and that will give her 24 points, which means she needs 8 points from 2-pointers, which is 4 2-pointers. So those are all the combinations. Those are all the combinations. And if you notice, you even saw a pattern. We didn't do the pattern in order, but you do 16, 13, 10, 7, 4, 1, 10, 8, 6, 4, 2, 0. So you can see that these are actually connected. They follow the same pattern. They follow the same constant rates. But those are all her possibilities, what Emily could have done in the basketball game. She could have made 4 2-pointers and 8 3-pointers, 7 2-pointers and 6 3-pointers, 10 2-pointers, 4 3-pointers, 13 2-pointers, 2 3-pointers, 1 2-pointer, 10 3-pointers, 16 2-pointers, and 0 3-pointers. All of those are options. That's the table. Your table should look like that. Maybe the order is a little bit different, but those are all the options possible. Nothing else is possible. Now for the next part, it says let x be the number of 2-pointers. So x is the number of 2-pointers, and y is the number of 3-pointers that Emily scored. Write an equation to represent the situation. Well, look at this. We can actually use this. You notice I kind of already did the equation. X is the number of 2-pointers. So X was my blue right here. So X, every X got multiplied by 2. And if Y is the number of 3-pointers, every Y we did got multiplied by 3. And we added these together, 32 and 0, 2 and 30, 26 and 6, 20 and 12. All of that got added together, and all of the answers are 32. That's exactly what we did. We did X's, we did the 2-pointers times 2, plus the 3-pointers times 3 has to equal 32. That's exactly what we did when we finished the table. And that is our equation. You can look and see that is the equation. We have 2x plus 3y equals 32. And this is the equation for Emily's basketball game. That is the equation for Emily's basketball game. After we finish the table, notice how I put these clues on here to help, but we found out that 2-pointers times 2 and 3-pointers times 3 equals 32 points altogether. That's exactly what we did. 2 times the 2-pointers plus 3 times the 3-pointers equals 32 points. And so this is kind of what we're doing today. Let's go to page 124, and we'll do a few more exercises together just to keep practicing this. For this one, and this is a little bit easier because they actually gave us the equation. They gave us the linear equation, x plus y equals 3. And what they want us to do is find 5 solutions and then plot the solutions as points on the coordinate plane. So we need to finish the table. So this is finish the table and graph. Now, for x plus y equals 3, you can see they did not tell us what to pick for x. They did not tell us what to pick for y. It's our choice. So we get to pick what we want. Now, so you can pick whatever you want. You can pick absolutely anything you want. You can pick negative numbers. You can pick positive numbers. You can pick small values. You can pick large values. You can choose whatever you want for this. But for me, I'm going to pick x's, and I'm just going to say 0, 1, 2, 3, and 4. Keeping it simple, keeping simple numbers. Now, I actually have to solve this. So x is 0. Remember, the equation is x plus y equals 3. So this time it's 0 plus y equals 3. Well, this tells me that 0 plus y equals 3. So y, 0 plus blank equals 3. So y has to be 3. 0 plus 3 equals 3. But when x is 1, I get 1 plus y equals 3. Well, remember, you can to solve this, do the subtraction property of equality, do minus 1 on both sides. And you get y equals 2. Well, what about for when x equals 2? We have 2 plus y equals 3. Remember, again, subtraction property of equality, to get y all by itself, we do minus 2 on both sides, and we find out that y equals 1. Well, what about when we have 3 plus y equals 3? Remember, subtraction property of equality, isolate the y, do minus 3 on both sides, we find out that y equals 0. Finally, the last one, we got 4 plus y equals 3. We need to do subtraction property of equality, take 4 away from both sides. Well, on this side, 3 minus 4 is negative 1. So there we go. They gave us the equation. We picked whatever we wanted for x. They gave us the equation in 2 variables. We picked fixed values for x. These are the fixed values right here. Remember, fixed value was one of our vocabulary terms. Fixed values, these are the fixed values. We chose them. We could have picked whatever we wanted. Maybe you chose the same things as me. Maybe you chose something different. But this is the equation in standard form. We fixed values for x, and we found the y solutions. Our next step is to change this chart into ordered pairs so that we can plot them, that we can graph them. Well, remember, in our vocabulary, we know ordered pairs go x comma y, just like that. So let's change this table into ordered pairs. So we have 0 for x, and when x is 0, y is 3. When x is 1, y is 2. When x is 2, y is 1. When x is 3, y is 0. And when x is 4, y is negative 1. So there we go. Those are our ordered pairs. So we have the table, we have the equation they gave us. We did our fixed values. We solved the equation 5 times. And we used our fixed values and our solutions to find ordered pairs. And these were our fixed values. These were the solutions. And we put those together to make the ordered pairs. One more step, we have to plot the solutions on the coordinate plane. So for this, we actually need to pull out our graph paper. So I'm going to slide it over so I can still see my coordinates because I need my coordinates when I graph. And when I make my graph, I need to think about what my x-axis and y-axis need to be. So if I look at my x's go from 0 all the way up to 4. So this is exercise 1. So my x's go from 0 to 4, and my y's go from 3 to -1. So I'm going to go right here. I'm going to go a little bit above. So my y's, I make a plan for my y's, and I make a plan for my x's. And this is where it might take a little bit of practice with you. But let me show you why I made my graph look like that. Because right where this is x, this is y, where x and y hit is called the origin, and that's 0, 0. Now x goes 1, 2, 3, 4, and this is -1 on the x. Now, why did I draw my x this big? Because I looked at my x's here and I saw 0, 1, 2, 3, 4. So all of the x's in my coordinates, all the x's in my ordered pairs are on the graph. And I did the same thing on my y. All of my y's in the ordered pairs, 3, 2, 1, 0, -1, 3, 2, 1, 0, -1. I see all the x's I need. I see all the y's I need. All the x's I need, all the y's I need. So that's how I set up my graph. Now I need to actually plot them. So 0, 3, so x is 0, so I go to 0 on the x, and I go to 3 on the y. That's 1 point. 1 on the x and 2 on the y. I do 1 on the x and 2 on the y. Where they hit, that's a point. 2 on the x, 1 on the y, 2 on the x, 1 on the y. They hit right here, so that's a point. 3, 0, 3 on the x, 0 y. They hit right here, so that's a point. 4x, -1y, 4 on the x, -1y. They hit right here. That's a point. So that's my graph of all 5 points. And that's exactly what yours should look like. I fit all 4 of my points on that graph. So recapping for exercise 1, they gave us the equation. They wanted us to complete the table, so we fixed 5 values for x. They could be whatever we want. I picked those. We solved the equation to get our solutions for y. And then when I have my y solutions, I make my ordered pairs. And then I graph my ordered pairs. So that's what we're doing today. It's a good little preview. What I'd like you to do now is I'd like you to try number 2 yourself. Try exercise number 2 yourself. Try doing everything just like we did for number 1. Just do it on your own. So pause the video, give it a shot, and try your best on this. And then resume the video when you're ready to check your work just for number 2. So hopefully you pause the video and you're ready to check your work. Once again, we have 5 solutions and we get to fix our own values. So again, I like to keep it a little bit simple. So I'm just going to do let's see, what do I want to do? I want to do I'll just do 0, 1, 2, 3, and 4 again, just to keep it simple. Now I need to solve it. So I get 2 times 0 minus y equals 10. That's 0 minus y equals 10. That's minus y equals 10. So that means y has to be negative 10. Because negative 10 equals 10. Another way to do this is you multiply negative 1 times both sides. Negative y times negative 1 is y. 10 times negative 1 is negative 10. So we got negative numbers on this. Maybe I should have thought a little bit more about my x's, but we'll see how it works. We're going to have negative y's. That's not a problem. Now we have x is 1, so we could do 2 times 1 minus y equals 10. That's 2 minus y equals 10. Remember the subtraction property of equality? We do minus 2 on both sides. That gives us negative y equals 8. And again, we need to, because y is negative, let's multiply it by negative 1. And the multiplication property of equality tells us we do 8 times negative 1. So y turns into negative 8. Now this is a linear equation, so maybe you already figured out the pattern. Let's see, 2 times, so we do 2 times x. This time it's 2 times 2 minus y equals 10. 4 minus y equals 10. Negative y equals 6 after we do the subtraction property equality, do minus 4 to both sides. Then again, we need to multiply by negative 1 to make y positive. We need to multiply by negative 1, so it turns into negative 6. Now we have 3, so we do 2 times 3 minus y equals 10, which is 6 minus y equals 10. We get negative y equals 4. Multiply both sides by negative 1 gives us a positive y and a negative 4. When x is 4, we do 2 times 4 minus y equals 10. That turns into 8 minus y equals 10. We do minus 8 from both sides. We get negative y equals 2. And then we want y to be positive, so we multiply by negative 1. And we multiply 2 by negative 1 to get negative 2. So those are the values that I got. Maybe you picked something different for x. If you did, you got different y's. If you picked different x's, you got different y's. But our graphs will look the same. We'll just use different points. They'll go in the same. But let's get our ordered pairs in the order of x comma y. When x is 0, y is negative 10. That we take the fixed value and we take the solution. When x is 1, y is negative 8. When x is 2, y is negative 6. When x is 3, y is negative 4. When x is 4, y is negative 2. Now you can see I have my ordered pairs. I'm ready to plot these solutions or graph the coordinates. So let me slide it over so we can still see our coordinates on the paper. And let me get my graph paper. There's our graph for number 1. Let's add a graph for number 2. And I need to plan to make sure all of my x's and all of my y's show up. So if I look at my y's, they're all negative. So I'm going to go down. This is going to be my x's, and x's have to go up to 5, up to 4. So I'm going to go x that far. And x gives me, right there, all of my x's in my ordered pairs are on the graph. 0, 1, 2, 3, and 4 are there for x. Now I need to plan my y's. This is a positive 1 on a y, but I need to go all the way to negative 10. So I go, so negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, and I left a little bit of room for an arrow because we know it keeps going. Now, if you picked different x's, your graph will look a little bit different than this. This is just using what I picked. But let's get the graph going. So for 0, and negative 10, we go 0 on the x, negative 10 on the y, it's right there. 1x and negative 8 meet right there. 2x and negative 6y right there. 3x and negative 4y, 3x and negative 4y go right there. 4x, negative 2y meet right there. And that is my graph of my solutions. So I have my ordered pairs, and I turn them into a graph so you can see where they go. Now, you might have picked different x's, but you will still see that your ordered pairs follow the same kind of line. You can see the line in the linear equation. The line goes up like that. Yours should follow the same direction, even if you pick different numbers. So, equation, fixed values, do the work to get the solutions, make the ordered pairs, and then make the graph. Let's check and see our next work on is the same exact thing on page 125. Number 3 is going to be the same thing. Number 3 is going to be the same. But let's look at this real fast to see, well, let's try to remember how we got a lot of negatives for number 2. Maybe we can fix different values for x to make this more workable. So when I'm looking at this, I see x plus 5y. Well, I equals 21, so I want it to be pretty easy. So what I really want to do is I want to think, okay, well, what can make this easy? What should I start with? And here's a little advice I'll give you for this one is instead of fixing values for x on this one, let's fix values for y. Let's fix values for y instead. And the reason is because the y is the one being changed. X does not have a coefficient. Y has a coefficient. So when the variable has a coefficient, that's the one we want to start with. So that's just a typical advice. I'll write on here. Fix values for the variable with a coefficient. Fix values for the variable with the coefficient. So instead of starting with the x's, we're going to do the y's because it does not matter which one you do. So this chart, we're actually going to fill this table in a little bit backwards. But we're going to start with the y's because that has the coefficient. So I'm just going to keep it simple. 0, 1, 2, 3, and 4. You can even do negatives. Maybe on one of these other ones I'll do negatives. But let's do 0, 1, 2, 3, and 4. Now, when we solve the equation, we're going to start with y's. So we're going to do x plus 5 times 0, because remember, we're substituting for y's. That gives us x plus 0 equals 21. X equals 21. So when y is 0, x is 21. What happens when y is 1? We get x plus 5 times 1 equals 21. That's x plus 5 equals 21. And you know the subtraction property of equality, do minus 5 to both sides, and you find out that x is going to be 16. Now, let's do y equals 2. X plus 5 times 2 equals 21. X plus 10 equals 21. Subtraction property of equality, do minus 10 on both sides. We get x equals 11. So x is going to be 11. Next one, y is 3. So we get x plus 5 times 3 equals 21. That's x plus 15 equals 21. Subtraction property of equality, minus 15 on both sides. We get x equals 6. See how these numbers are nice and easy. Last one, y is 4. x plus 5 times 4 equals 21. That turns in x plus 20 equals 21. Do minus 20 on both sides for the subtraction property of equality. We find out that x equals 1. That's our table. Now, just for fun, I'm going to pick a different color. What would happen if you did not start with y's and you start with the x's instead? Let's say you did not listen to me and say, Mr. Bear, I'm just going to do 0, 1, 2, 3, and 4 for the x. Well, what happens when x equals 0? That's what we're going to see. Remember, we have x plus 5y equals 21, and you were stubborn and you said, Mr. Bear, I'm going to do x's. X is 0. So we get 0 plus 5y equals 21. That's 5y equals 21. Divide both sides by 5, so to get y by itself. And now you have 21 over 5. You have a fraction answer if you start with the x. That's why I told you to start with the y's. Because when we started with y's and did 0, 1, 2, 3, 4, we got whole numbers for x. If you start with the x's 0, you get fractions. In fact, I think you get you get a lot more fractions if you start with the x. That's why I told you, look at the coefficients, and the one with the difficult coefficient, the 5y, you do the y's first. It's going to make it so much easier for you. Going to make it so much easier. Because now we can make ordered pairs that do not have fractions, because graphing the fractions would be tricky. But graphing the whole number ordered pairs is easy. So we still go, so even though we start with the y's this time, we still do the ordered pairs in the xy order. So we did y's first, but we still start with x's because this is an ordered pair. Order is important. So the x goes first, 21 and 0. Then we get the 16 and the 1, 11, 2, 6, 3, and 1, 4. Now you'll notice on this might be a little bit tricky to graph, but I'm going to show you how. That's what I'm here for. So let me slide my paper over so we can just see the ordered pairs. We don't need to see all the other work. I just want to look at the ordered pairs. Let me get my graph paper right here. And there's number 1 and 2, but I'm going to slide it down so we just have room for number 3. Put number 3 right here. And now you'll see I need a plan. So the y's, all the x's are positive. That's good. I don't need to go I don't need to go negative. And all the y's are positive and 0. I don't need to go negative. So I'm just going to do the y's first. I need to see a 0 all the way up to 4. So I'm going to do like this. Because here's the y and here's the 0. There's -1 just to show it. 1, 2, 3, 4. So I see all the y's I have. 0, 1, 2, 3, and 4. Now for the x's, there's -1 on the x. I have positive x's, and I'm going all the way up. I need all the way from 1 to 21. So you have a couple choices here. One choice is to count by 2's. You can count by 2's to save a little bit of room on your graph. But because I have lots of room on this graph, I'm just going to count by 1's, and I'm going to go out 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and a little bit extra for my arrow. That's my x. You can see it went far, but that's because the numbers got pretty big for ordered pairs. 1, 2, 3, 4, 5. I'm writing down the numbers so that it's easy to read and to double check that I made my x-axis long enough. I want to be able to read it and see if it's long enough. And yes, there it is. See? Long enough. Now I'm ready to start plotting my points. 21x and 0y. Well, here's 0y. Here's 21x. They meet right there. That's a point. 16x, 1y. 16x, 1y, they meet right here. 11x and 2y, 11x, 2y meet right here. 6x, 3y, 6x, 3y. They meet right here. And 1x and 4y, 1x, 4y. Those lines meet right there. And so that's what our graph looks like. That was much easier than doing fractions, which is why I started with the y. And remember, I started with the y because that's the one that had the coefficient. So I had to pay attention. I had to fix my variables, fix my values intentionally with purpose. I thought about it before I picked them, because sometimes people will just do, okay, I'm just going to do 0, 1, 2, 3, and 4 for x always. Well, I showed you that doing that will actually make your life harder this time. You need to think about what values you are picking and why you are choosing them. This time we started with y because it was going to make whole numbers instead of fractions. And I knew that because I just gave you the little trick. A way to check is look for the coefficients and do the coefficient variables first. So if y had a coefficient of 5, I picked that one first. Then so I picked the y's, we did our work, we found the x's, we took the x's and the y's, made our ordered pairs, and that helped us make the graph and plot our points on it. This is working well so far. Let's keep going with number 4 on page 125, and you're going to see that they're throwing a fraction at you to trick you. Consider the linear equation 2/5 x plus y equals 11. Now, just about what we talked about with number 3, looking at the coefficients, you see we have a fraction coefficient, 2/5. And it says, will you choose to fix values for x or y? So are we going to pick to fix values for x or y this time? And using what I just told you for number 3, we will fix values for x because it has a more complicated coefficient. Now, for all of you who want a little bit extra, y does have a coefficient. Y's coefficient is 1. But 2/5 is more complicated than 1. That's why we say we're going to fix values for x because its coefficient is more complicated. Fix values for x because it's more complicated. And B, are there specific numbers that would make your computational work easier? Explain. So looking at this, when we fix values for x, what x's should we pick? What x's should we pick? Well, if you're talking to me and I see this and I see 2/5, I say, well, if I pick 0, that's pretty easy because it makes the fraction go away. 2/5 times 0 is 0. So I like 0, but what happens if I pick 1? If I pick 1, I have to do 2/5 times 1. Then I have to use the subtraction property of equality and do 11 minus 2/5. That's going to be annoying because I have to do subtracting fractions. So really, what numbers do I want to pick? I want to pick numbers for x that change the fraction into a whole number. That's what I want to pick. I want to pick numbers for x that will change the fraction into a whole number. So what numbers will do that? Well, look at the denominator for the 2/5. Because if I do 2/5 times 0, that's 0. Another easy one is 2/5 times 5. Because 2/5 times 5, 5 is 5 over 1. 5 divided by 5 cancels. That just gives me 2. And then if I do 2/5 times 10, why is 10 easy? Because 10 is 5 times 2. The 5s cancel, and 2 times 2 is 4. The next one I want to pick, 2/5 times 15. Because 15 is 5 times 3. The 5's cancel. I get 2 times 3, which is 6. So do you see why it's good to have a plan before you start just fixing values? Have a plan for your fixed values. Because some people do 0, 1, 2, 3, 4, 5, and I'm going to say you're going to have a lot of fractions. But I'm going to pick numbers that make the fraction go away. Like this, the fraction, gone. Start with a fraction, gone. Start with a fraction, gone. Start with a fraction, gone. All because I said, okay, the denominator is 5. How do I make the 5 go away? By multiplying by a multiple of 5. So I use 5, 10, 15. You know the next one's going to be 20, and then 25, then 30, because all of those will make the fraction go away, because 5, 10, 15, 20, 25, 30 all have 5s in them. And the 5 we multiply by will cancel the 5 in the denominator. So this is why it's very important that you have a plan for what you're doing. So that's our plan. I think they're going to want us to actually do it now. Yep. 4 or 5C, they want us to actually do, they gave us the equation and we want to do this. But we know what we're going to pick because we know we liked 0 because 0 is going to make the denominator go away. We know 5 was going to make the denominator go away. 10, 15, and 20 are our other choices to help us out. Because we know 2/5 times 0 plus y equals 11. 0 plus y equals 11 means y equals 11. 2/5 times 5 plus y equals 11. 2/5 times 5, the 5's cancel, so we get 2 plus y equals 11. After the subtraction property of equality, find out y equals 9, because we do minus 2 on both sides. 2/5 times 10 plus y equals 11. Well, remember the 10 turns into 5 times 2. The 5's cancel. We get 2 times 2 is 4 plus y equals 11. Subtraction property of equality, y is going to be 7, because 11 minus 4 is 7. Keep going. 2/5 times 15 plus y equals 11. Remember, the 15 is 5 times 3. The 5's cancel. 2 times 3 is 6 plus y equals 11. Subtraction property of equality, y is going to be 5. Last one, 2/5 times 20 plus y equals 11. 20 is 5 times 4. The 5's cancel. We get 2 times 4 is 8 plus y equals 11. Subtraction property of equality, do minus 8 on both sides. We get y equals 3. There we go. See how picking the right x's give us really easy y's to work with? That's why you need to choose the x's that make sense for the equation. Do not just pick them randomly, pick the ones that make sense. And we write our coordinates now. We write our ordered pairs. 0x was 11y, 5x was 9y, 10x was y equals 7, x equals 15, y equals 5, x equals 20, y equals 3. And now we have our coordinates. We are ready to graph them. So we slide it over. And we probably have enough room right here underneath number 3. I can do number 4. I could probably squeeze in number 4. Y's need to go up to 11. So all the y's are positive up to 11. So let's do this. So let's do 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Just enough. I just had enough room on the bottom of my page. That's my y's. Here's my x-axis right here. How far do I need to go? I need to go out to 20. So x's start at 0 and go all the way to 20. So I'm going to go all the way out to 20. Let's do one. Let's make sure I went out far enough. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, I went to 21. That's fine. So there we go. There's my x-axis. There's my y-axis. Now I'm ready to put my points on here. So 0x, 11y. So 0 on the x, 11 on the y means it's going to be right up here. 5y, not 5x, 9y. 5x, 9y means it has to be right here. 10x, 7y, 10x, 7y means it's going to be right here. 15x, 5y, here's 15x, here's 5y, and it is right here. And then 20x and 3y, 20x, 3y, they meet right here. And that's my ordered pairs plotted, graphed. Done. So you can see how choosing the right x's really helped me out on this. Always pay attention to your choices. Make sure you're making choices that make sense with what you're doing. Let's work on, I think it's the last exercise, exercise 5. Exercise 5 says, at the store, you see that you can buy a bag of candy for $2 and a drink for $1. Assume you have a total of $35 to spend. You're feeling generous and want to buy snacks for you and your friends. Write an equation in standard form to represent the bags of candy X and the number of drinks Y that you can buy with $35. So candy is X, drinks is Y. We add them together, we want to make $35. But candy is $2 each, so X's are going to be times $2. $2 times the candy plus $1 for a drink. $1 times the drinks is Y. So $2 for every candy plus $1 for every drink should be $35 altogether. So that's the equation. We have 2x plus y equals 35. That's the equation that you can use to find out how much candy and drinks you can buy for you and your friends. $2 for the candy plus $1 for the drinks should be $35. 2x plus y equals 35. Going to the next page, page 127. That's the equation we're going to use. 2x plus y equals $35. And what we're going to do is, remember, I told you before, we need to find solutions, and so we're going to start with the one with the coefficient. So we're going to pick ones for x. We're going to choose for x because x has a more complicated coefficient than y. Y's coefficient is 1, and 2 is a little bit more complicated. So let's pick for x. Let's say that you and your friends, how much candy do you want to get? Let's say you want 0 candies and a whole bunch of drinks. So 0 candies and all drinks. If you want 0 candies, you're going to do 2 times 0 plus y equals 35. That 0 plus y equals 35. That means if you buy 0 candies, you can get 35 drinks. Not bad. What happens if you want 2 candies? Notice I'm not going 0, 1, 2, 3, 4 just to mix it up a little bit. If you want 2 candies, that's 2 times 2 plus y equals 35. 4 plus y equals 35. Subtraction property of equality, minus 4 on both sides, y is 31. So if you buy 2 candies, you can have 31 drinks. Candy, drinks. Let me label my x and y. Okay, let's pretend you want, I don't know, 10 candies. 10 candies. So you do 2 times 10 plus y equals 35. That's 20 plus y equals 35. Subtraction property of equality, do minus 20 on both sides. So if you buy 10 candies, you can have 15 drinks. Maybe 15 drinks is still too much. I don't know how many friends you have, but that's a lot. Maybe you want to buy, I don't know, 12. Let's say 12 candies. So you do 2 times 12 plus y equals 35. That's 24 plus y equals 35. Subtraction property of equality, do minus 24 on both sides. You get y equals 11. So buying 12 candies gives you 11 drinks. So I don't know if you went to the movies with 10 people, but 11 drinks sounds like a lot. Let's say, 15 candy. You really like candy, you want 15 candies. 15 boxes of candy. You do 2 times 15 plus y equals 35. That's 30 plus y equals 35. Subtraction property of equality gives you y equals 5. So if you buy 15 candies, you get 5 drinks. Excuse me. But that is the chart that we made. Now you can see we figured out the equation, and then I just picked different values for x. Now, I don't know what you're going to want. I don't know. You and your friends are probably going to have to talk about it and do the math. But if you know how to do a linear equation, the math gets easier. Because you say, well, if 5 people are going to the movies, then we could do this. If 5 people go, everyone can get 7 drinks. Or if 5 people go, we can get 3 drinks and 2 candies each. Or if 5 people go, we can get 1 drink each and 3 candies each. This is how you figure it out. So this is a real-world application of linear equations. These come in handy when you figure out how to buy things. One more step, it says, plot the solutions as points on a coordinate plane. I'm not going to do that part. I've graphed 4 times for you, so I think in this lesson, I'm just going to skip that part so that the video is a little bit shorter and we can get started right away on talking about the work you're doing independently today. So I'm not going to graph that, but that'll be fine. You have an idea of what I did, of how to graph. If you need more help with any of this, reach out to me. Send me a message, send me an email. I'll help you with this some more. Also, they do help you on this more themselves. Like, here's the lesson summary you can use to help you to get help. It just basically summarizes everything we did. There's the exit ticket on page 129. But here we go. Homework helper on page 131 gives you another problem. If you need more help with how to do this, they give you the equation and they talk about how they chose what they wanted. And you'll even see again that they picked values for y because it makes things easier, because that's the one with the more complicated coefficient. So the book agrees with me. So if you need more help, look at the homework helper. If you still need help, reach out to me. I want to help you do your best on this. Watch the video again if you need to. Go back, pause it at certain parts to see the work, to hear me talk about it again. Use the homework helper. If that doesn't work, reach out to me and I will help you, I promise. But after you feel ready to go, work on the problem set on page 133. There's only one page of a problem set. It's doing the exact same work that we did. For number 1, it looks exactly the same. But for number 2, 3, 4, and 5, you're going to have to build your own table. You have to build your own table for 2, 3, 4, and 5. So you're going to need some scratch paper. You are also going to need graph paper, because on all of these it says plot the solutions, plot the solutions, plot the solutions, plot the solutions, plot the solutions. So you'll need to show me your work, you'll need to show me your tables, and you'll need to show me your graphs. But this is the problem set, so you know all of my answers to the problem set are on the Google Classroom. You can check your work with mine. So do your work, check your work, and then ask me if you are still confused by anything. And then when you feel confident, go back to the exit ticket that was on page 129 and work on the exit ticket independently, and I don't have answers to the exit ticket because this is what you take a picture of and turn it in. But they're asking you to do pretty much the same thing. They're asking, does this point work? Does this point work in this equation? So take the x and y from the point, put it in, and see if it works. And then it's wanting you not to do 5 solutions. It says find 3 solutions for this equation and then graph it. So they gave you a little piece of a little graph right here to graph your answers. Think about what you're going to choose for your x. Think about what you're going to choose for your y. It is a little bit of a complicated equation because both variables have coefficients. But if you think about it, I'm sure you'll do well. If you get stuck with anything, remember, I am here to help. Reach out to me if you need to. But have fun, do your best, and I will see you for the next lesson.